Alright, this is graphing a linear inequality. I know it's a line because I've got both x and y, but the other big hint is that I got a big old grid over here. So I'm going to do it the same way I graph a regular line. I still want y by itself. So I need to get this 2x to the other side. So I'm going to minus 2x minus 2x. Use my little trick of sneaking a plus sign in there. So I have negative 3y. I haven't done anything worth changing this sign yet. This is minus, not a negative. So is greater than negative 2x plus 6. And now I need to get y by itself. I'm going to divide out by negative 3, divide by negative 3, divide by negative 3. And so I'm going to get y, and this does change the sign. I divided by a negative number. That means this sign is going to flip direction. So change direction. A negative over a negative is a positive, but it doesn't get any prettier than that. So 2/3 x, and a positive divided by a negative is negative. So this is negative 2. So I'm going to start it off the same way I do all the time. This guy right here, he is my y-intercept, so I'm going to start at negative 2. And I am going to go, this is my slope, up 2 to the right 3. So up 2 to the right 3. Now, before I connect these with a line, I have a decision to make. Because with inequalities, I either do a solid line or I do a dotted line. And that is entirely dependent on this sign right here. If it has the equal to bar, it is a solid line. If it is just greater than or just less than, it is dotted. Since this does not have the equal to bar, this is a dotted line. So my only request is that you make it blatantly obvious that this is dotted. Do not make me guess which one you are doing. Same deal as always, it has to go all the way across the graph and as straight as you can make it. Now there's one more thing I have to consider here. I have to shade either this side to say all of these values work, or I have to shade this side to say that all of these values work. And there is a cheaty method and there is a true method. I'm going to go ahead and use the true method because I have the time. And so here's what we are going to do. We are going to choose a coordinate point, any coordinate point, so long as it does not live on this line. I'm going to go ahead and choose negative 4, comma, positive 3. So let me stick a little dot up there to remind myself. I've got negative 4, positive 3. So what I'm going to do is this guy is my x and this guy is my y. I am just going to plug them into the equation. I'm going to see if I get a true statement or if I get a false statement. So I've got y, or 3, is less than 2/3 x, so that's negative 4, minus 2. I'm going to go ahead and cheat a little bit. I'm going to turn this into a decimal because it's going to work out nicer, and we don't really need to do big math for this. So 2/3 times negative 4 is negative 2.6. So I've got 3 is less than negative 2.6-ish, minus 2, or that 3 is less than negative 4.6. So I have to make a judgment call here. I have to ask myself, is 3 less than negative 4.6? And well, that's simply not the case. 3 is much, much bigger than negative 4.6. So I'm going to look at my coordinate point that I chose, and I am thinking to myself, this is a false statement. And this is above the line that we drew. So all the things up here are going to be false statements. Therefore, I must color in the other side of the line. Now, that is the official way, choosing test points, but you could have done it a different way. If you would have done the cheaty method, you would know that if it is less than or equal to, you shade below the line. And indeed, that is what we ended up doing. We took this line and we shaded the area below it. I do not care which method you use during the test, But remember that this works in all, I'm sorry, this works in all the cases. This cheating method works in almost all the cases, so be careful which one you learn.